I hope you guys are doing well. We got an Algebra 2 special. Only you guys get to see this today. Here with Mr. Franklin, we're doing a little disc golf 6-foot challenge. Didn't notice, we're out burying. So our goal is the garbage can by the school bus there. This one's a little bit tricky because the parking lot is out of bounds, the school bus is a loss of job, and my wife, right over there, if you hit her, it's an automatic, for me at least, loss of wife. First throw, Mr. Franklin.
Like monster! I'm actually bad compared to Mr. Gimmel, so it's probably going to be Mr. Gimmel. Oh, that's parking lot for sure. Or not. Not even close. All right.
Oh no.
Nice.
All right, shot number 2 for Mr. Franklin.
Curve back. Or not.
All right.
Shot 2 for Mr. Gimmel.
Going for a mid-range. That way I don't. Actually, I might go with a putter.
Yeah, putter. You're close.
Putter because I don't want to go OB. Nice little pro shot.
Ooh, very close. Very close.
All right, so there's our goal. Mr. Franklin, shot number 3.
Likely it'll be 4 because I usually get 4s. Mr. Gimmel gets birdies and pars.
Thanks, buddy. All right.
Mr. Gimmel's par shot. Can he make it? He did. He par.
Yeah, go and finish. Shot number 4.
Shot number 4. What if I make it in?
-1.
-1 for making it
-1 if you make it in.
But I have to hit the actual metal?
Okay, if you make it in the garbage can, it's -1.
So better.
Yeah.
Okay. So then we tie.
Yeah.
Par and par.
Oh, man. Okay, so today we're looking at the 4-3C worksheet. I'm just going to be going over how to do each problem. So if you haven't tried the worksheet yet, make sure you stop this video, go try the worksheet, attempt it, and then come back and watch this video. Alright, so our first question is write in exponential form. So you take log base x of 4 equals 1/2 in exponential form. This will be, we have to recycle. So get x raised to the 1/2 equals 4. That's your answer for the first one. Second one, log base 3 of 9 equals 2 in exponential form. I recycle, I get 3 squared equals 9. So question 1 and 2 are pretty straightforward, pretty easy. Let's look at question 2, or question 1a and 1b. Question 2, let's look at how to write each of these in logarithmic form. So we do log the base, take the x, drop it to the base. Log base x of 5 equals 2. Because remember, a logarithm equals the exponent. Let's go and look at our second one. I do log base 2 of 9 equals the exponent, which in this case is x. Now remember, when you're doing these, if you had lined paper here, that would be all this would be on the same line. The x there would be below it. Alright, this one we actually did in the lecture yesterday. I did that one as an example, but I'll go ahead and do it again. Remember, the hint is to graph the inverse first. So what is the inverse of this logarithm? Well, I'm going to graph y equals 3 to the x. That'll be the first thing. And that xy table, let me move this down here actually. So first thing I'm going to do is graph y equals 3 to the x. So just take those two and bump them up. So my x, y table here, let's start with -2, -1, 0, 1, and 2. Well, 3 to the -2, remember negative exponent means I flip. So I get 1 over 3 squared, which gives me 1 over 9. So I get 1 over 1/9. Now the second one, 3 to the -1, well that's just equal to 1/3. 3 to the 0, that's equal to 1. 3 to the power of 1 is just 3. And then 3 squared is equal to 9. So those are the xy coordinates for the inverse here. But now let's go ahead and look at the actual log function. Let's just look at the log base 3 of x. That xy table is the inverse. These are inverses. So all I have to do is flip or swap all of my xy coordinates. So all I'm going to do is 1/9, -2, 1/3, -1, 1, 0. Where am I? 1, 0, 3, 1, and then 9, 2. So those are the actual coordinates for my original function. And the last thing I have to do is just plot this on the xy axis. So I take all these coordinates here and convert to my xy coordinates in my xy axis. So I get the first coordinate 0.11, -2. So I'm going to go 0.11 and then go down -2, which is right about there. 0.33, -1, right about there. 1, 0. Right about there. And then I get, just a second, I get 3, 3, 1, 2, 3, 1, and then 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, right there. So that is my function, right there. So that is y equals log base 3 of x. Alright, let's look at question 4a, where we have to evaluate this logarithm. So 4a, we have, this is log base 3 of 1 over 27. Now the first thing we're going to do is just set it equal to x. I'm going to recycle, so 3 to the x is equal to 1 over 27. Now maybe we can figure out what does the exponent have to be to make this equal to 1 over 27. So quickly we can say that I have to flip the 3 to the bottom because I need 1 over 27. And 3 to what power equals 27? Well, 1 over 3 to the power 3 equals 27. So mentally we can figure this out, that x has to be equal to -3. The negative flips it, 3 cubed is 27. So that's how you can figure out mentally just using our mental math. Another way we could do this is try and get the same base. So I'd have to move the 27 up to the top, so that'll give me 27 to the negative 1, and then 3 to the x is equal to, I know that 3 cubed is 27, so I get 3 to the negative 3. Since my bases are the same, that means my exponents also have to be the same, so x is equal to negative 3. So that's how you could solve that one, both just using mental math and computing everything. Let's look at example B. Example B, we have log base root 2 of 1/4. I'm going to set it equal to x. I'm going to recycle. And then I'm going to take the root 2 and rewrite it like this. There we go. So I don't want the radical 2 there. I want the base to be this, just the 2. And that will be equal to 1/4. Now I want to move the 4 up to the top. So I'm going to get 2 to the 1/2 x is equal to 4 to the negative 1. That flips everything. And then I know that 2 squared is 4, so I get 2 to the negative 2. Now since my bases are the same, that means my exponents also have to be equal. So I can set those equal to each other. I get 1/2 x is equal to negative 2. Now I just multiply both sides by 2. Those cancel, multiply by 2. And I get x is equal to negative 4. So that's how you'd evaluate example B, 4b. You could also use mental math there if you wanted to. Next, let's solve for x. So here, the x is in various places. Unlike the previous one, we just had the logarithm. Now x is part of the equation. I don't have to add it. So let's look at example A of log base 3 of x is equal to 4. Again, I recycle. You'll see that basically every single time we're going to recycle. So I get 3 to the power of 4 equals x, which 3 to the power of 4 is 81. Double check. Okay. So that one's pretty straightforward because it's just an exponent problem. Let's look at example B. Log base x of 1/16 equals 4/3. So again, I recycle. X to the power of 4/3 equals 1/16. I'm pretty sure I did this one in the lecture yesterday. Now the key here is that since x is not in the exponent, I'm going to take this left-hand side and multiply by the reciprocal of the exponent. Those will cancel each other out, and I'll be left with the power of 1. 4/3 times 3/4 is 1. But what I do to one side, I also have to do to the other. So this will be equal to 1/16 to the 3/4. So I get x is equal to, if this is a radical, the 4th root of 1/16 cubed. Now, I can separate this vertically, so the 4th root of 1, the 4th root of 16, and then cube all of this. Well, the 4th root of 1 is just 1, the 4th root of 16 is 2. So I cube that and I get x is equal to 1/8. Yeah, I'm pretty sure I did that one yesterday in the lecture. Example C, I have log base 3 of 1/81 equals x. So I recycle and get that. Now, We saw in 5a that 3 to the power 4 is 81, but I need to flip it. So I know that if I have 3 to the negative 4, that will flip this to get 1 over 3 to the just like that, 3 to the power 4, which will give me 1 over 81. So x would have to be equal to negative 4. So that's how we could do it kind of mentally, mental math there. But I could also do it like this. I could flip that up, 81 to the negative 1, 3 to the x is equal to 3 to the negative 4, and then my exponents, since my bases are equal, my exponents would also be equal, and there's my answer. Let's look at example D. Log base 1/4 of 64 equals x. So I recycle, just like that. Then I'm going to, I want to move the 4 up to the top, so that will give me 4 to the negative x, because it's negative 1x, so I just put the, I don't have to write the 1, just negative x, equals 64. Now, if I can get the 64 as a power 4, so 4 raised to what power is equal to 64? Well, 4 cubed is 64. So since my bases are the same, that means my exponents also have to be the same. So negative x is equal to 3, so x is equal to negative 3. And that's the answer for question 5D. Could also use mental math there if you wanted to. Again, it's just kind of which method you prefer, which makes the most sense to you. Last example is E. Log base 2 of 32 equals x. So I recycle, 2 to the x is equal to 32. So 2 raised to what power is equal to 32? You could just literally plug that into your calculator and just do 2 times 2 times 2 times 2 times 2 until you get 32. But we get that x is equal to 5, because 2 raised to the power 5 is equal to 32. Alright, so that's the worksheet, all the solutions to the worksheet. The quiz tomorrow, tomorrow. So quiz is going to be on sections 4-2 and 4-3. So it's going to be on both. So make sure you guys review 4-2 and the section on 4-3. It's going to be pretty similar to this whole worksheet. You guys will have questions similar to that. You'll have to convert from exponential to logarithmic and vice versa. You'll have to graph. You'll have to solve questions like this. I mean, this is pretty similar to the quiz for the 4-3 part. And you're also going to have the 4-2. So make sure you guys review that. If you guys do need extra help, shoot me an email. I'll try and answer it. Or if you need video chat help, then let me know. We can get scheduled time. All right. See ya.